Ladies and gentlemen, it's my great pleasure to introduce the former director of HAO, Michael Knolker. Many of whom, you know him very well. We go back a long time, maybe not as far back as the Coronacope. But I think what we're going to hear in the next 10, say 15 minutes, is a kind of very innovative approach to how we can look at our star, but maybe other stars too. And I'll hand it over to Michael. Thank you, Michael.
Thank you, Scott. Actually, Scott has suggested this title of the talk, and in thinking about it a little bit, I really liked it because it refers to one of my favorite movies, and I'm going to show you in a minute why it has to do with the approach that I'm taking here. Imagine that through a twist of fate, a scientist gets stuck somewhere in the American West, and the OMB and Congress are not very generous with funding, so he has to rely on the local blacksmith and the technology that is around at the time to build advanced instrumentation. Next slide, please. So this is what the approach was in that movie, and if we can start the movie now. So he took, if you go on the, here we go. So you probably remember that. Now this is the Spanish version. I found this on YouTube. Okay, next slide, please. So here's the analogy. Through a twist of fate, I found myself confronted in our lab with a piece of equipment that came out of long-term storage, which was given up. And at first I got very annoyed because I couldn't drive through the lab anymore with my scooter. But then I got interested. This piece of equipment is the Coronacope 2 that Gordon Newkirk flew the last time in 1965. This is exactly 50 years ago. So since we have the 75th anniversary, this maps kind of very nicely. And I was reminded at that moment of a collaboration that we had, Greg Card and I, for some time with Webster Cash here at CU, who is advancing the technology of externally occulting telescopes. He wants to look at planetary systems out in the solar neighborhood and to study planets in detail, and he has used our vacuum facility in the past to promote the idea. He has not been able yet to get off the ground. So I got this crazy idea, well, maybe if we can use one of his shades with the Coronascope, because he had mentioned on and off that his new treatment, optical theory, makes him believe that he could also build better occulters for solar observations. So I got in contact with him, and the result is that we have put together a team here on the HAO side. Many of them you have met this week. On the CU side, it's Webster Cash and other people. And next slide. And now, seriously, the idea is that we want to investigate the potential of applying a Starshaped technology to solar coronagraphs, which will need that we restore the Coronarscope 2 instrument as a baseline. They were putting everything on 35 millimeter film. That's not cool anymore. So we're going to use a digital camera, and actually it will be Tim Brown's STARE camera out of another NASA project. And then we will, in detail, characterize the characteristics of the polarization that can be achieved as compared to three circular occulter concept that the Coronarscope was using. The same concept, by the way, that is used in LASCO 3 on SOHO. And what I found compelling is that we would do this lab test with an instrument that we know has flown, we know how it performed, so we could have a really nice baseline. Next slide, please. The science case. Now, it has been luckily elaborated upon already earlier today. Observing the K corona will remain a very important issue in the future in advancing coronal magnetographs. The K corona, which gives you a clean signal of density, is the crucial complement on other data that you can use, and to deploying K coronameters in space will of course mean that maybe we can have other angles in the future. It also, improving K coronameters basically bears the promise that you, in space-based telescopes, you can get closer to the sun than with the realizations that we have so far. Personally, I also come to this subject that I haven't worked on in the past, based on the stunning success of combining numerical simulations of sunspots by Matthias Rempel with precision magnetic field measurements in the photosphere. I know he's now up to extending such simulations consistently into the corona. I believe that will also fuel the need to observe coronal dynamics with the best resolution possible. So that's the science case. Next slide, please. Here's the past. This was the Coronascope 1. The rod that is sticking out there out of this gondola is actually the guide telescope, the finding telescope for the sun. You see this 3 occulta contraption there on top. And the coronagraph was out in the open. The balloon gondola is the gondola that actually was first developed by Martin Schwarzschild 1957 for the stratoscope. And we actually have it here in-house. Next slide. This is the Coronascope 2. Old picture in the lab. Now it was enclosed. You have all these baffles to trap any kind of internal stray light. And you can see on this rod the 3 circular occulters. Next slide. We were able to find, in HAO being an orderly place, all the old construction drawings with all the details. And in studying those and studying the papers that were written, I am at awe and with great respect on the quality of the work that was done and the quality on how papers were written in those days. Next slide, please. Here's the present. Great things are done. You can see space-based coronagraphs, as Joan is stressing all the time, are missing out on the inner corona. Next slide. This is, of course, the exciting new development that my little thing would potentially complement. Next slide. This is the Coronascope 2, and you can see it right now in the museum. And the 3 occulta assembly got dinged on landing. Now here comes my personal experience. That's nothing to restore that. Oh. It's really no problem to restore that. This must have been a very elegant landing as compared to the sunrise landings. And we can show you upstairs in the lab how the hardware looked there. Next slide. So this is just a glance at what Webster Cache has developed in terms of designing occulters, and what they ultimately look like is they have these almost flower petal shapes. These shapes are being produced at NIST with great precision, or in a way with the same techniques as computer hardware is done on pure silicon. And the one that we will have to produce will cost $50,000. Next slide. This was Webster's cache runs, Webster cache test runs in the NCAR vacuum tunnel, and he could demonstrate that he could get the contrast below 10 to the minus 10 with a 50 millimeter occulter, which is basically the size that we are shooting for. Next slide. This is tentative, sort of the shape that a solar occulter will look like. Next slide. This is the vacuum tunnel. This is the equivalent of this blacksmith place that we are using here in the Wild West, because it was one of the failings of my directorship that I never could get it fully modernized and taken care of, because it is falling between the responsibilities of NASA and NSF and UCA facilities. I hope that at some point it can be the magnificent facility again that it once was. Next slide. Just a little more on the layout. Next slide. You can look at that outside later. Next slide. We will use the HMI polarization calibration unit because part of our labs test will use polarized light, very important in studying white light corona. Next slide. So this is the tentative measurement program. 580 nanometers is sort of a sweet spot for coronal observations, broadband. And 840 is close to where Newkirk Coronascope 2 observed. Next slide. If the results are compelling, and the proposal that we have put forward to NASA is just about the lab tests for now. We feel that we would have a good shot at a proof of concept balloon flight. We would have a telescope structure that is basically flight certified. We would, with the addition of a CCD and of course all the electronics will be new, we would use the Sunrise gondola in such a proof of concept flight. Now the gondola can carry a lot bigger payload, as you know. So if it comes to such a flight, we would invite other people who want to maybe test other instrumentation onto the same flight, and that might be a compelling opportunity. That's it.
Thank you, Michael, and I will say that this was actually a challenge that I laid down to Michael. Could you do this in terms of the Coronascope? And I think it does provide some very exciting opportunities to have. We don't really have time, but I'll have one quick question, as long as it's quick, and it's not from Phil. Ricky.
What might be the observational advantages to using the Starshaped like occulter?
Better contrast and the ability, now here comes the pointing accuracy into play, and that's a whole world in itself. But in principle, the ability to construct externally occulted coronagraphs that can go a lot closer to the sun. And so you could monitor a much wider range. Higher contrast also means you can go farther out. You could cover a much wider range to monitor coronal dynamics.
Thanks again, Michael. And Liz, thank you also.